saturation currents depends only on intensity of light or number of photons per unit time, whereas this point corresponds to the stopping potential. Next is if we draw graph between intensity and voltage, keeping frequency same but number of photons or intensity different, then we get a graph like this. So we can say that intensity corresponding to third point is greater than that of second, greater than that of first. However, if we keep the intensity same but changes the frequency, then we get a graph like this, and corresponding to the largest magnitude of stopping potential, we have largest frequencies. So it follows the same order. Then again, if we draw graph between stopping potential and frequency, we get a curve like this. And it is an instantaneous effect, so it takes 10 is to power minus 9 second or less for the photoelectric effect. Now let's study the explanations. So it is that frequency is greater than threshold wavelength, threshold frequency or less than wavelength. Photocurrent increases with increasing voltage up to a certain limit, where it becomes saturated, which depends only on intensity or number of photons, but independent of the frequency. However, there is a clue in that, because intensity in general also depends on the frequency, but here the point is that change in frequency is less than 5%, so that we can assume that intensity is just dependent on the number of photons and neglecting the dependency on the frequency, as there is a very less relative change, so it's not gonna be more significant. Next is for a corresponding retarding potential, there is a photocurrent is zero, that we call as the stopping potential, which depends on frequency of light but independent of the intensity. Now if we change the intensity with frequency remaining same, then stopping potential will remain the same, but saturation current will change, and it will be greatest corresponding to the largest intensity. Next is if intensity is constant and we change the frequency, then saturation current will remain same, but the stopping potential will change, and it will change in a way that corresponding to the greatest frequency, we have the greatest uh, stopping potential. Then next is all these results are valid only when frequency of photon is greater than a certain threshold frequency or less than a certain threshold wavelength. So these were certain points regarding the photoelectric effect. I hope it will save your precious time and energy. You can make any doubt, you can ask it out in the comment section. Thank you and have a nice day.